Hey everyone, welcome to the next video in the PongGDX tutorial series. So in this video, we're going to finish up working on these paddles for both sides. Not yet getting the AI implemented for this paddle yet, just because we need to get the ball moving as well. So I figured in this one, we'll be taking a look at getting both these paddles attached to their respective goal zones, cleaning up our prismatic joint method, and understanding why we're getting this weird disjoint in our prismatic joint as far as how the paddle is connected to the goal zone. So to start, let's take a look at the problem we have here, which is always a good way to approach what you're working with, just analyzing the occurrences that are taking place. So you'll notice that the joint is actually bending about like in between like the center of these. So obviously our local anchor A is set to the wrong position for what we're working with. So what we're going to do is we're going to change the method signature to the create prismatic joint to include a local anchor A and a local anchor B. Although we won't be using the local anchor B, it'll at least offer us the flexibility to be able to use it later if we need it. And from there, we're also going to be figuring out why or how to incorporate linear interpolation so this is a little bit smoother, because obviously if players have that access to instantaneous motion, it's going to kind of throw them off. So you want to ease to the position, one, to offer a small variability in gameplay, and two, just to make it feel nicer. The controls need to feel a little tight, and so but not this tight. It just is it's a little hard to really snap to where you're going as far as like playing Pong. It also looks unrealistic as far as how fast the paddle is moving. And then we'll also be setting some bounds. So as you see, the paddle is leaving the screen. We don't really want that. So let's jump into the code real quick. As I said, first thing we should do is edit this method and add in anchor A, vector 2, anchor B. And once you start getting past, that 80 letter line, you kind of want to wrap the line at that point. Make it at least look nice if you can. And so yeah, I just wrap that around to the next line. And so now we're going to have this get set to the anchor A, and then pdef.local anchor B dot set anchor B. Okay, and so now that we have that, we can come back into our game screen. We're gonna have to change the create prismatic joint down here, and we'll be passing in the new vectors. So new vector 2, and that's gonna be I think the right place was 36 divided by, or what would that be? Yeah, divide by ppm, and then 0. So let me think. What was that? What was that set to? Yeah, I believe, yeah, that was right. And then we will also need new vector 2, and that's just 0, 0, because those aren't changing. So again, we have another line wrap here. So let's just take this one and break it and wrap it, and that'll look a lot nicer. But I mean, as far as like something like this, if it's just like a false that's overhanging on this line here, which is kind of nice that IntelliJ includes that. It helps you program a little smarter to keep your code clean. Just, this is okay, but once you start breaking way past it, then definitely do a word or a line wrap. Just wrap that line up. So with that, I think that should be the right position at the least. So that should be our first problem that we need to take care of. And we're still only working on the goal left and the paddle left. Okay, so yeah, that's a lot more aligned. Although I think it might be 1 pixel off. If I did my math right, it's either 36 or 35, but for the time being, I don't think it's really gonna hurt us to have it 36. So 10, because that's how wide the paddle is. So the width of the paddle, or the radius from the center, is 5. So that's 5 units, and then it's out 40 from the left. So yeah, that would be 35. I'm just going to change to 35 because I do know it's 35 now. And the next thing we're going to need is to create another joint, and this is going to be for the right paddle. And so this will be goal left, and we'll change that to goal right, and go paddle left to paddle right. And so the limits, as you remember, are just the upper and lower limits. So that's going to be on the y-axis for the axis that this joint is being hydraulicked on, like up and down, the way it waves. And so those are correct. And then we're going to have to change this to -35, I believe. We'll have to check. It should just be an opposite of this one, though. And again, the local anchor B should stay the same. So let's check out what we got now with those updated coordinates. Okay, perfect. So now the left and right paddle are both joined appropriately, and we can see that just from how things are set up. So next thing we want to do, we need to work on this whole smoothing aspect, but you can't see it right now. But you'll notice how like this wall isn't really fighting the object. In a previous video, I talked about setting the local axis of the joint. Now, this is where we are going to configure like the direction that this joint operates on. And right now it is actually set to be on the x-axis. So it's supposed to slide out and in instead of up and down. And we don't see that because I'm manually modifying the y value of the paddle using the set transform. And so it's essentially breaking the joint. And that's why we're able to also go past the upper and lower limits very easily without any kind of fighting. It just kind of glides right through. So in order to fix that, we need to come back to our joint builder, and we're gonna have to change the pdef.local axis A, and we're gonna just set that to 0 and 1. And so to understand this, these are just like the x and y values for like the angles. It will make sense, like you set this to 1 if you want to go on the x, you set this to 1 if you want to go on the y. I'm pretty sure it's like a rotation value. I haven't messed around with it too much. I just know those are the ones you set to work on an x and y level to set it relative to the actual joint itself instead of the body that it's joined to. So now I believe since we set that, if we load it up one more time, we'll be able to see a little bit more resistance. So now things are like, they're still moving the same, but now if I try pressing this, oh, you know what? I don't think we'll actually be able to see it until I implement the linear interpolation. So yeah, why don't we just do that real quick? So if you're familiar with my camera tutorials, you'll know there's the simple formula of a plus b minus a times your interpolation value is how you do a simple linear interpolation. And that's just kind of what we're going to do for the mouse. And for the time being, until we get proper handling or controller support, I'm just going to put this right here. Again, we do have our to-do revise to remind us that we do want to clean this code up. So like the second we get the chance, we want to jump on that. And so to get the lerp, we'll have another float lerp, how about mouse lerp equals paddle left dot get position dot y plus mouse position to world minus paddle left dot get position dot y. You know what? Wait, maybe I have that backwards. Should be a. No, that's right. Yeah, and then times. I normally do either like 0.1 or 0.2 f, and that's gonna be my essentially like the smoothing factor of how fast it gets to the mouse position. So now when I have mouse slurp, instead of moving it straight to the mouse position to world, and I run it, should see a smoothed effect. So now you're feeling it. It's like a little bit gummy, which is kind of what you want. It gives it that gameplay feel instead of that instantaneous, okay, I'm just giving you what you want, do whatever, how you feel you want to move the mouse. And so now we'll see how it's kind of fighting. It's like slowed. My mouse is going past it instead of matching it. And then it kind of pops out of the arena. And that's because we're breaking the upper and lower translation limits. And 2, we're also colliding with this chain shape that's on the outer wall of the arena. So those are just 2 things that we're having a problem with. So with that, now we need to look into setting up our boundaries. And to do that, all we have to do is just create kind of like a boundary or a few if statements on this mouse slurp. And again, we're going to keep this close to the to-do revise because it is a little messy. But because we want to do some testing with our ball first to make sure our Pong idea works, and that's a working game, we're just kind of throwing it in for now until we establish a good way to handle input and controls. So this is just a way for us to be able to interact with our world, get functioning parameters set up, and then we can move forward. And that's how you kind of learn to write something that works, refactor it into something better, and keep refactoring, harden the code, make it better, make it better, make it better. And so that's how you kind of work on top of revisions, just making those changes. And so we're going to have let's see, we'll have an if mouse slurp if mouse slurp is greater than, so that'll have to be times ppm because that is in screen units, is greater than camera dot viewport dot height, and that should actually be less than and mouse slurp is greater than, sorry about this, should be greater than 0. I just had to think about making sure I'm getting these right. So now for this simple if statement right here, this conditional is just going to be saying like, okay, is our alert position, is it within the bounds of the camera? So the camera viewport height and the bottom of the camera, and so that should be 0 and camera viewport dot height. And so let's check that out real quick, see what we get. Might have to do some small adjustments. Okay, so we are getting, it is sticking now at least, but we're still breaking that wall a bit. So to recognize that, we actually were given a pretty simple case here where we can see that it is at least stopping, but it's stopping halfway. And what we should notice about this is it's stopping halfway of the height of the paddle. And so thinking about that, we are missing something here. So we need camera viewport dot height minus what is the height of the paddle? We have 10 and 40, so it should be 20. Again, these are values that once we move them out into the paddles, like once we move these bodies out into paddle objects, we will not want to hard code them. And so this will be a positive 20 because it'll be 20 up, and then this is 20 down into the camera view. And so now when we run it, we should be able to see that the boundaries are in place. And so, oh, that's not, whoops. Okay. This needs to be less than 20, camera viewport dot height, mouse slurp greater than 20. That should have, why didn't that work? Because this is in screen units. Oh, whoops. Okay, that's my bad. I just forgot to multiply this by ppm. There we go. So I wasn't, oh yeah, so that's an easy way to check. If your numbers aren't right, then just make sure you're using screen units against screen units and world units against world units. So now when I run it, and look at that, we are getting the proper bounds on our paddle. So with that, you know what, we should actually refine that. So there's one thing to notice about that, like a lot of people might take that action to look at the bound that you were given and then just match it against what you were passed. And here's a quick example of why you should always double check every test scenario you can. I'm gonna move my mouse really, really fast off the screen, and look at that. So if you notice, it lerps for a second, and then if I move my mouse a little bit more, then it kind of like snaps in. And that is because I'm saying, like, if the mouse lerp, which is like way bigger than the position it's able to break, is like out of the view, then at that second it will stop with the transition. It won't allow it to continue until the mouse gets close enough that this ×2 multiplier is big enough to allow it to move forward and down to the edge of the screen. So a way to refine that is we can break this up into two if statements. And so now that we have it broken up, we'll say, like, if this is greater, we'll flip it real quick. We'll say that mouse lerp equals 25, or I'm sorry, so that's the camera viewport dot height. So that's going to be camera dot viewport dot height minus 20 divided by ppm. Turn it into screen units. And then down here, we're going to have mouse lerp equals 20 divided by ppm. Make sure you're using floats just everywhere, might as well. And we'll move this out. So now it's always going to be keeping an eye on that mouse lerp, but if we hit the walls and we have something that's larger, it'll just continually go to the walls. At the least, it should, at least, from what I imagine. And that is because I forgot to flip this too. So get that back in. And so now I'm moving my mouse up all the way really quick, and you'll notice that I'm now getting the right kind of output. And that's because it's putting a bound on the actual lerp value instead of putting a bound on when to call the transform, which is what we want. We want the transform to always be able to occur. We don't just want to stop it in its tracks if it finds a value that's out of bounds. So now we're getting that really nice, smooth paddle movement, which is what we're looking for. So yeah, with that, what we've accomplished today is we've fixed our joints, and we applied the joint to the right side as well. And we also created linear interpolated values for the paddle smoothing motion. And so now it's a little more like fluid feeling. And you can turn that to a 0.1, see if you like that feel a little bit more, or even in between like 0.1 to 0.3. And any value in between that is, it'll give you a pretty nice smooth value. And we also changed the local axis of the prismatic joint, which is another thing that we had to do in order to make sure our boundaries worked and not just setting the X and Y values of the paddle explicitly. So with that, I think I'll leave you guys to it to kind of mess around a little bit more, and then in the next video we'll be looking at moving the ball around and possibly even scoring, just to do a little work with contact sensor or body sensors and a contact listener. And so with that, hope you liked the video. Like, comment, subscribe as usual, and I'll see you guys in the next one.